All right, greetings, Cyber Patriots. Here we are working from the Cyber Julio channel, and we're going to be talking some more about our Cisco content. We're in chapter 3 and of the next module, and we're going to talk a little bit about some communications protocols. A lot of stuff that's conceptual here, not as much hard skill stuff, but some important concepts, a couple of exercises I think we need to do. So we're going to check this out, add some commentary. I'll advise like where you probably need to go into a little more detail and where you could probably just read it, get the idea, and move on for time's sake. We've got about 39 slides, I think, in this one. So let's get into some network communications and network protocol and communications in Cisco. So we've got some, this class activity, this example thing. Again, this is just background stuff we're giving for setting the stage for understanding communications concepts. And they're going to do some comparisons with concepts in a company or here in this real life. So they've got a diagram. You can check it out. You can play this. They're just trying to take the idea of having a personal conversation and relating it into its components of who's the source of the message, how is it transmitted, who's the receiver, how do they interpret it. They're going to unpack analogously a personal conversation so that they can then translate the same ideas into network communication. And so we've got some stuff where they haven't done the rules right. They've got looks like some Spanish or Portuguese or something, and some bad grammar and so forth. You translate it and they have it corrected. Makes it important. You need rules, you need standards, make communication work. Then there's message encoding. They'll talk about that some. Again, just building the concepts for communications that we understand so that we can understand the parallel ideas on the network side of things. Formatting and encapsulation. So they're going to have the analogy of a postal letter being, to use the word encapsulated or inside something. Like you would think of a capsule that's got the content inside of it. And the capsule in this instance is the envelope. The data part is the letter that's inside that's got the thing that's actually going to be read. But the from and to part of the message have parallels in network communication. So again, they're just building this analogy. It's a good way to teach the concept before they get into some of the more in-depth details. Okay, again, more stuff on the human communication, message size, how you break up messages into smaller pieces. Again, setting the stage for the network parallels, access method, same idea, setting some more framing here. Unicast messages, she's talking just to the one student. So that's uni, like think like, unicycle or any other word where it's got one object to it. A multicast, multi means several. Here she's talking, but there's two recipients. And then a broadcast message, which is everybody. Network parallels there too. The protocol suite, they're going to start talking about protocols, and notice they're starting to layer. That's going to be important momentarily. A content layer, a rules layer, and a physical layer. I would read this because that's going to set things up for some layered protocols that we're going to have a few slides out. Now they're starting to break this out into the network side of the world. There's the IP and then there's the data. One is the envelope, what says how to get there and what's being transmitted and where it's coming from. Those kind of things that are what you would have on the envelope exterior content. And then there's the data itself, the actual letter, the message that the sender wants to get to the recipient. Protocol interaction. So this is the first of two different layered views of how protocols work on the network. Learning this stuff is just part of being in IT. I can remember when I went through some of this exact same stuff back in the early 90s when I was learning some things in my first IT job. This is one of two. This one has 4 layers to it. There's going to be one that has the infamous 7 layers of the OSI model. And you can see there's an application layer. That's really what we see. The transmission layer, the TCP, we'll talk about more of that later. The internet IP layer, the internet layer of things, and then the Ethernet or network access layer. This 4-stack one is in some ways conceptually easier. The one that they break it out into 7 gets a little bit murky for most folks, differentiating some of the ones in the middle. So here's some examples. at the application layer. A lot of these things probably unfamiliar. That's a lot of IT acronyms there, but stuff that is important. These things will come. But HTTP, of course, that's web traffic. We've talked about that. There's FTP. We've talked about that in some of our exercises, FTP servers. And then some of these other things we're going to get into down the road. Okay, here's some history. Is interesting. I would read it, not necessarily pertinent from a cyber patriot standpoint. Again, here's our 4 layers and some stuff that's in there. Again, some things from a usage standpoint, they're going to be new, but you can just click each one and go through that definition. They'll probably, I think there's going to be an exercise where they hit you up on these, so you might need to come back to this one before you do the exercise and work on these. And again, this stuff will seem could seem a little bit on the mysterious side when you're first getting into it. Later on, though, it will start to make more sense. So just work on, we'll call it the dictionary definition of the stuff, and then and later on it'll consolidate and start to jive in your minds. All right. So the next thing is a given message. So when you actually send a package from your web client across to the web server or reverse, it's broken up into that layer. So this is like one package that is going to be sent from one address, like you sending a letter from your house to another house. And it's got all this protocol stuff that's the sender and the recipient and what the address is, so the mail post office can figure out how to get it there. And then there's the data itself, the letter, the actual message that we want to communicate, like give me the Google web page or play this YouTube video. And this is all of the stuff of, well, how do you find the YouTube server and where is that and what port is this running on and all that kind of stuff. And we've got some Java stuff that we can play. All right, here's our first exercise, and this one probably, like I said, might need to go back a few slides to review this before you do it, but I would recommend doing it. We'll take a little bit. You might even just take one at a time and do the check with one exercise at a time, just to not get frustrated and work on one at a time. And if one has trouble finding, if you guess wrong 3 times, probably time to go back a few steps and reread the definition on that particular. Open standards, important idea, not necessarily essential from a cyber patriot competition standpoint. Internet standards, so there's people that decide all this stuff. Very important from an industry standpoint, not necessarily so much from a CP competition standpoint. Working groups, again, some super smart people doing some great work to make all this stuff work so that across vendors and different kinds of technologies and this whole internet thing, the absolute miracle, which is why anything works on the internet, is because of folks like this figuring out how to make these standards work. Okay, researching network standards, that is completely optional because it's not super essential from a competition standpoint, but decent exercise, so we'll consider that one optional. Now we're going to do the other. Made reference to the fact that we had this 4 layers of this TCP/IP model: the network, the internet, the transport, and the application, which is kind of working, I guess, from top down. You might think of these as at these higher levels, the application level. That's the stuff we deal with. If I'm running my browser and I can see what's going on in the browser, that's stuff happening at the application level, the things that I as a user interact with. As you move down to the transport layer of how the browser's dealing with the session of talking to the web server, things where they're talking and doing things behind the scenes that I wouldn't necessarily see as a user. The internet layer, where across the network it's trying to figure out, okay, where is that server and which hop on which router do I need to go to next, and that sort of stuff. So you've got an internet layer here, and then this network access layer, which you're getting down to Ethernet, cables and that kind of stuff. Now they break it out more in the OSI, and this is, honestly, I had not seen this until last several years when I was doing my studying for certification tests and that kind of thing, way back in the Windows NT days in the 90s. This was the one that I had to study and learn and memorize and do all the exercises on. So they're going to start to unpack the 7 layers of the OSI model here a little bit next. And there we go. So we've got the physical layer, plugging in wires, the data link layer, data between devices, the network layer, individual pieces going over the network, the transport layer, segment data, reassembling it, because you might get the stuff across different routers and in different order, and somehow you got to take all these pieces and put that jigsaw puzzle back together into a coherent message. The session layer services to the presentation layer. So this layer is defined by what it does for this layer. Organizing its dialogue, managing data exchange. Pretty nebulous definition, I think. And then the presentation layer, common representation of the data. So this is framing the data up so that it's in a format that it's going to be usable when we put it to the application layer. Process-to-process communications. But I was thinking the application layer is the app. That's where it's happening at the level where we as users see it. And again, I would get some idea of these, because down the road, if you do any certification tests like the CCNA content or any of the Microsoft engineering, even some of the security certs, CSSP, Network Plus, there's a lot of them. They'll make reference to this, and you'll be accountable for having at least a passing knowledge, if not an in-depth knowledge, of the 7 layers of OSI. Now we're back to the 4 of the TCP/IP model. And again, we've got some definitions, so I smell a matching exercise coming up. And now again, twice they've done this now actually, where they're going to map 3 layers at the OSI, translate to 1 layer in the TCP/IP side. So a lot simpler. And they're just showing, so if you're dealing with one, how these map. Again, very interesting, kind of on the academic side of things from a Cyber Patriot standpoint, but stuff you need to start getting ready for from an industry prep standpoint. Okay, and here we go. So what you're going to do, they mess with you a bit because they don't all line up. So you're going to take each of these, find its definition, drag it over, and then if you want to, you can even do one at a time, and it'll tell you if you got it right. And then if need be, back up a couple of slides and recheck your definitions. Okay, the packet tracer, investigating the TCP/IP and OSI models in action. We're getting a lot of other work on the packet tracer tool. We had a lot of exercises in Chapter 2, and we'll be doing a lot more with the network build and getting ready for the Cyber Patriot. So this one, definitely optional from a Cyber Patriot standpoint if you want to do it, but if you want to skip that one, I don't think it'll mess you up to skip this one. Communication, segmentation, again, just a little video that we'll play to explain the concept of that messages aren't necessarily a single envelope tells a single envelope with a letter in it doesn't tell the other device everything it needs to know. They're usually broken up into several letters, and then they have to all be opened and reassembled and reordered. And then you've got it because folks on the same network, and we'll show this one where he sends some of his and then some of hers, and so you've got to get that stuff put back together, and how that happens is some of the things they're defining in the OSI. So protocol data units, encapsulation. Again, this is talking about packaging. What's the packaging around network communication, and then what's the actual data on the inside. And they're kind of breaking down within a given packet where that is from the header or the packaging info versus the data itself. Again, good concepts, things we need to understand. Not necessarily stuff we need in depth yet for Cyber Patriot. Again, here's more. So here's a given packet. So this is a letter, I guess, in their analogy on the internet. Here's the data, the letter content itself, and here's and here we get the from and the to and the zip code and how we're going to get it, how the post office is going to know how to get it from user A, user B across the router. De-encapsulation, so taking that stuff and I guess doing it in reverse. Again, we've got a graphic, so check that out. And then we've got another exercise for moving some stuff around. So you can do that, do your checks. If you need to, back up a few slides and recheck the definitions. Network addresses. Okay, so this is going to be, actually this is going to get practical in a minute because we're going to start talking about stuff that happens on the network and how we do network addressing and IP addresses. So we're about to get into IP address, how they're broken up, IP address versus network address, and some of that. Because everything on the internet is based on IP addresses. So you've got an IP address that's unique to my laptop I'm working on and my wireless router that's in the house, and then each device and the computer you might be watching this on. So each thing has a unique IP address so that it can be uniquely found or it can uniquely send stuff across the network to other devices. and we'll talk about those. I think we're getting those in just a second. Data link addresses, MAC addresses, probably not needed to get too far into that level of thing just yet. Again, understand the concept of layer 2 stuff, but not essential. The network side, the IP addresses are. That's going to come up a lot. So read through this one. I would pay some attention here, devices on the same network, because within an IP address, for example, this 192.168.1.1 hen, what they're saying is this is almost levels of specificity. So notice 192.168.1 and 9, 162.168.1 and 1 hen. So they're showing how that up through the first three, we call these blocks that are separated by periods, we call these octets. We won't get into the mathematics of why, but binary math is factoring on what's called an octet. But just remember that each section of numbers is called an octet, and they can go from as low as 1 up to 255 within each one of the octets. So when you see the numbers being the same for these first three octets, but then only the last two numbers are different, 110 on the user's machine and a 9 here in this FTP server that the user is talking to. So these are on the same network. Now there's some things we'll get into with subnetting where that doesn't mean they're necessarily on the same network, or it could be that things where you have where only the first two numbers are the same, and even the third number is not the same, and they are on the same network. So it's not just a simple assumption that if the first three octets are the same, but it's only different on the last section, the last octet. It's not quite as simple as that, and they're going to get into that some too. But what they're saying is, here's the network address, 192.168.1, the first three, same thing, 192.168.1, that first three. So that means they're on the same network. See, the FTP server's here, the user's here, they're talking to the switch, so they're not having to go out to any of these routers and off to the internet and all that kind of stuff. So the switches, the routers, the gizmos, network gizmos within the network, they can figure that much out. So that's like if that's like inter-office mail. I mean, if it's there within someone's building and you put it in the mail to go, all they got to know is like, oh, that goes from Joe's office or his department to another. It doesn't need to get the post office involved with, you don't send it to the post office to do an inter-office mail within a given building. You need them when it needs to go outside the building. And so this is telling us that this is inside the building. If it had different numbers in the earlier sections, depending on that subnet mask thing, it could go outside. So there's network section and the host section. And again, all of this is the envelope, and then there's the data of what the actual content is trying to go from a user to server. So hopefully that's not too confusing. Check that out. It's going to do some descriptive there. Please read that. It will be important. Now on a remote network, now watch the numbers change. Now we've got 192.168.1.110. That's the same IP address we had before, but needing to talk to devices with completely different IPs, 172.16.1.1, nothing's the same on either of these two. So now we're having to take the letter and send it through the post office, these routers, to get from one spot to another. And again, the network number here differs from the network number here. So we can't just sort of handle that mail delivery just down the hall or on the same floor in the building. That's going to go out and leverage the delivery services. And these routers do the work of figuring out how to get things from one network, this 192.168.1 network, to how in the world does it find 172.16.1? Well, they've got tables of stuff, almost like we would think of a phone book. They've got tables of knowing how to figure out, the routers figuring out amongst themselves. Well, I've got content from this network where I am. I need to find somebody, another router who can get something to this network over here. And the routers have tables and they communicate with each other to figure that stuff out. But point being, you see different numbers here. That means it's got to get into being routed outside somewhere. Again, important concept. Give that a good read. Installing Wireshark. Wireshark is awesome, but we're not going to get into that yet. But what it would do is it's again optional activity. But you download Wireshark and then you can run it on your computer. And there's other tools like it. Wireshark, I guess, would be considered the most popular. But you can, and free, you can install that on your computer and you can sit and watch activity on your computer at a pretty detailed level and see traffic coming and going and so forth. It takes a little bit to know what you're looking at, and often you're usually looking for something. You usually don't just sit there and read Wireshark. It's It's not like a novel you'd read. It's more, I guess, you think of like a dictionary and encyclopedias. There's a reason you're going to check something out. Maybe there's something wrong with the computer. Maybe you're having trouble communicating. A lot of times, if you think you've got malware, you can find it by looking at Wireshark and saying, hey, wait, there's some communication happening from my machine that doesn't look right. So you can use it usually for diagnostic purposes to find a problem. But again, not necessarily something you would just sit and watch for fun by any stretch. But again, optional activity, not sure it's going to be pertinent from a cyber patriot standpoint, but down the road, as IT professionals or IT security professionals, having the skills with a Wireshark or another one of the network sniff tools will be important. Okay, and then the lab to watch network traffic. So again, I would consider it optional. That's Wireshark. Can be for in-depth. That can be a class unto itself. It was, I think, just the one security class I took several months ago. It was, I think we spent about a half a day of just doing Wireshark work, learning how to ferret out the stuff that you wanted when you're looking at all that traffic going across your computer. It's kind of overwhelming too. The first time you see it, it's like, wow, I'm just sitting here with my browser open and there's all kinds of stuff going on behind the scenes. So it's kind of eye-opening too when you first start to see how much is happening beyond just what you see happening on your browser or in your email session. Okay, so here's the class activity that is guaranteed to work. Well, what's the point of that? I mean, if it's going to work for sure, then what's the need? So, but again, that's optional thing to do. And then we slip to the summary. So the biggies there, do those matching exercises on the definitions, read over the TCP/IP stuff, getting those layers, getting a decent idea on those layers, get the concept of the network part of the address versus the host or the specific computer or other device on the network, the host versus the network part of the addressing, and getting there on learning those, both the 7-layer and the 4-layer. That's going to come back, kind of like when I talk about the CIA in security keeps coming back. No matter where you are, you're going to see that. Anytime you deal with the network stuff, you're going to run into those. You're going to run into that OSI model and that TCP/IP model. So it's good to get familiar with those. But just get through the exercises, get the concepts. This is still building block stuff, not things that I think we're going to see too much of from a competition standpoint. Wouldn't anticipate that anyway. But we need the building blocks so we can get to more in-depth stuff when we start doing the practical work on the Cisco side. Because if you don't know how to configure IPs and that sort of thing, you're not going to be able to configure the devices and set up the networking that we're going to need to. All right, so that's chapter 3. Keep working on that, and we'll see you back when it's time to start talking about module 4.